Now let's move on to the second part, the water cycle. Water carries nutrients, sediments, and pollutants from the continents to the oceans via surface runoff, streams, and rivers. These materials can be carried for thousands of miles on ocean currents. Water also carries atmospheric pollutants to the Earth's surface when they dissolve in falling rain or snow. The water cycle, or hydrologic cycle, summarizes how water, in liquid, solid, or gaseous forms, flows through the environment. Oceans are the main reservoir in the water cycle, holding 97% of all water on Earth. Fresh water, what we need to survive, accounts for less than 3%, and 2/3 of the amounts are trapped in glaciers, snowfields, and ice caps. Less than 1% are in forms we can readily use, and that includes groundwater, surface fresh water, and rain from atmospheric water vapor. In the water cycle, we're going to talk about 4 parts: evaporation and transpiration, precipitation, runoff, and surface water, groundwater, and the human impact on the water cycle. Firstly, let's look into evaporation and transpiration. Water moves from oceans, lakes, ponds, rivers, and moist soil into the atmosphere via evaporation, which are sped up by warm temperatures, strong winds, and a greater degree of exposure. For example, if an area is locked of its forests or converted into an agricultural or residential area, it would lose water more readily than a vegetated area. Water also enters the atmosphere via transpiration, which is the release of water vapor by plants through their leaves. On a smaller scale, water also enters the atmosphere when it evaporates from the surface of organisms through perspiration or sweating. Transpiration and evaporation act as natural processes of distillation, as water escaping into the air as gas leaves behind its dissolved substances. Next, let's move on to precipitation, runoff, and surface water. Water returns from the atmosphere to the Earth's surface as precipitation when water vapor condenses and falls as rain or snow. This moisture may be taken up by plants and used by animals, but much of it flows as runoff into streams, rivers, lakes, ponds, and oceans. The amount of precipitation varies greatly from region to region, helping give rise to our planet's variety of biomes. Now, let's talk about groundwater. Some precipitation and surface runoff water soaks down through soil and rock and becomes groundwater, which is water found beneath layers of soil. Groundwater recharges aquifers, which are sponge-like regions of rock and soil that are underground reservoirs of water. The upper limit of groundwater held in an aquifer is referred to as the water table. Aquifers can hold groundwater for long periods of time, so the water can be quite ancient. In some cases, the groundwater takes hundreds or thousands of years to recharge fully after being depleted. Groundwater becomes surface water when it emerges from springs or flows into streams, rivers, lakes, or the ocean from the soil. Lastly, let's move on to the human impacts on the water cycle. Human activity affects every aspect of the water cycle. Here are some examples. Damming rivers slows down the movement of water from land to sea. Holding water in reservoirs increases evaporation. Removing natural vegetation by clear-cutting and developing land increases surface runoff, decreases infiltration and transpiration, and promotes soil erosion. Withdrawals of surface water and groundwater for agriculture, industry, and domestic use depletes rivers, lakes, and streams, and lowers water tables. The emission of pollutants into the atmosphere that dissolve in water droplets changes the chemical nature of precipitation, therefore sabotaging the natural distillation process that evaporation and transpiration provide. Water shortages also has given rise to conflicts worldwide. And that brings us to the end of the water cycle.